Hello everyone, this is Dr. Webb. In this video we're going to look at derivatives, particularly the first and second derivative, and look at how they affect the shape of functions or the shape of curves. So let's start with the first derivative. So I think we remember the first derivative, it tells us about the slope of a function. The slope of the tangent line, it tells us about the average rate of change. So first, if the first derivative is positive, well, then that means that the slope of the function is positive. So if we have a function, its slope is positive, well, then what happens as we're going left to right? The function's going up. And so we're going to say the function is increasing. What if, on the other hand, we have the first derivative is negative? Well, if it's negative, that's saying the slope of the tangent is negative, and so as we go from left to right, the value of the function is going down. So we'll say the function is decreasing. So if the first derivative is positive, the function is increasing. If the first derivative is negative, then the function is decreasing. What about if it's 0? Well, if it's 0, the slope is 0. Well, what do you think about line of slope 0? It's just a horizontal line. So at that point, if the derivative of a function is 0, it's neither increasing or decreasing. The function is horizontal there. Okay, and these are things we're pretty familiar with, working with the first derivative. What about with the second derivative? Right, so the second derivative tells us how the first derivative is changing. Okay, so if the second derivative is positive, this means that the first derivative is increasing, because this is telling us the change in the second derivative is positive, means f prime of x is increasing. Okay, so if it started off positive, over time it got more positive, so it got steeper. If it started off negative, then it became less negative. Okay, and you can kind of see in each of these what has to be happening. So if you're going up, and then you have to be going up faster and faster and faster, you're kind of curving upwards. If you start off going down, but it has to flatten out, it's going to go like that. So what has to happen in both of these? Well, you notice this is curving, and it's kind of curving upward. Okay, and so if the second derivative is positive, it means the slope of the function is increasing, and the function is curving upwards. On the other hand, if the second derivative is negative, well, this means the slope of the function is decreasing. So if it starts off positive, then it's going to turn into being less positive. So that's sort of like start off steep, flatten out, or if you start off negative, it's going to turn more negative, and so become more negative. And so in both of these, you can see that the function is curving downwards. Okay. And so what we say is that the second derivative tells us about the concavity of the function, right? So if the second derivative is positive, that means that the slope is increasing. And so think about slope increasing. So there it's starting negative, going more and more positive, curving upwards. This is concave up. On the other hand, if it's negative, so we can say we start with it positive, and then it flattens out, and then goes down the other way. This is When the second derivative is negative, we're going to call that concave down. And one way to kind of remember this is concave up is like a cup. Concave down is like a frown. Okay, so let's think specifically, let's be real careful and think about drawing these curves, connecting the sign of the first derivative and the sign of the second derivative together. I think this is a really helpful way to think about it. Okay, so we're going to start off with the first derivative positive and the second derivative positive. So the function starts off increasing, and as time goes on, it's going to be curving more and more upwards. Right, so we're going to start off positive. So I'm thinking about drawing the function there, tangent there, and then that tangent has to be getting more positive as time goes on, and so it's curving up like that. Okay, so that's positive curving up. Function going from left to right the whole way. The tangent lines have positive slope, and as time goes on, those tangent lines the slope gets higher and higher. What if the first derivative is negative, but the second derivative is positive? Well, so now we're starting off with something whose slope is negative, but as time goes on, it gets less and less negative. So it flattens out, right? So we can think about at the beginning, very steeply going down, and then as time goes on, flattens out. And if you look at, let's change colors. If you look at the tangent lines here, so that's a very negative tangent line. As we go further down, tangent line is less negative. Okay, so the tangent lines, they're all negative, the slopes are all negative, but they're getting less negative as time goes on. Okay, so decreasing concave up looks like that. Okay, what if it's increasing in concave down? Right, so it starts off with a very positive slope, and as time goes on, flattens off. Okay, so very positive slope at the beginning, time goes on, flattens off. Right, so very positive, flattening off. Emphasize these tangent lines in blue. Okay, so increasing concave down looks kind of like that. Last but not least, what if it's decreasing in concave down? So if it's decreasing, slope's negative, and then as time goes on, it gets less negative. So it starts off negative, time goes on, it gets more and more negative. So time goes on, getting more and more negative. Okay, so decreasing concave down, starts off kind of flat, ends up going very radically down. Okay, so let's put this together with an example. So here's a cubic. We want to figure out where the function is increasing and decreasing, and where the function is concave up and concave down. Then we're going to try and make a rough sketch. Okay, so first thing we should do, find the first and second derivative, right? So this is just a polynomial, so we're just using the power rule over and over again. For the x cubed, 3 comes down, left with x squared, minus 3x squared. The 2 comes down, 2 times 3 is 6, times x, minus 24, derivative of x is just 1, and then the plus 10, when we take the derivative, that goes to 0. Okay, so there's our first derivative. So we want to figure out when this is positive and negative, so let's see if this factors nicely. I can pull out a 3. So I have x minus 2x minus 8. And then looking at this, I believe we can write this as 3 times x plus 2 times x minus 4. Okay, so this quadratic, it has zeros at minus 2 and at 4. So it's 0 at both of these. And now we got to figure out what it is to the left of minus 2, in between minus 2, and over to 4. Easiest way to do this maybe is to just plug in a point, right? So for minus 2, I can plug in minus 3, say. So if I plug in minus 3, I'm going to get at minus 3, if I'm just plugging in minus 3 for x in the factored form, I get 3 times minus 1 times minus 7, so that's going to be 21, which is positive. If I plug in 0, is nicely between minus 2 and 4. And so when I plug 0 here, well, if I plug 0 in up to the top, that's going to cancel off the 3x squared and the minus 6, leave me with just minus 24. So that's pretty negative. And then say if I try, say 5, so 3 times 7 times 1 gives me positive 24. So that's positive again. So we get that it's increasing to the left of minus 2 and to the right of 4. So it's increasing when x is less than minus 2 and x is bigger than 4. And then it's negative in between minus 2 and 4. So decreasing when x is between minus 2 and 4. Okay. And then we need to do the concavity, concave up and concave down. So we need to take another derivative. So we need f double prime. So we're just going to take the derivative of f prime, probably the first line before we factored it. That'll be the easiest. So derivative of 3x squared, 2 comes down, left with 6x, minus derivative of 6x is going to give me another minus 6. Then minus 24, that's going to go to 0. So the second derivative is just a line, 6x minus 6. And think about this as being 6 times x minus 1. And so this is going to be positive when x is bigger than 1, negative when x is less than 1. So we have concave up for x bigger than 1, concave down when x is less than 1. Okay, so let's piece this together. So we have that it's increasing between when x is less than minus 2 and x is greater than 4, decreasing between minus 2 and 4. We have that it is concave up when x is bigger than 1, and concave down when x is less than 1. So I'm going to make a think about the x-axis, try and plug all these points in here. So I have -2, 1 pops up, and 4 pops up. Okay, so at -2 and to the left of 1, this is increasing and concave down. Between -2 and 1, it's decreasing and concave down. Then at 1, the concavity changes. And so at 1, this turns to concave up, but still decreasing. And bigger than 4, then it's increasing and concave up. Okay, so if we put these together, increasing concave down, that looks roughly like that. Decreasing concave down, that looks roughly like that. Decreasing concave up, that looks roughly like that. Increasing concave up, that looks roughly like that. Right, so I'm going to give myself some space up here. Make a rough graph. And so we have between -2, to the left of -2, it's increasing up to -2, and then it starts decreasing at 1, and then at 4, it starts increasing again. So this is at -2. This is at x equals 4. Then in between where this concavity changes, this is at 1. Places where concavity changes, this has a special name. This is what's called an inflection point. Okay, and inflection points are special. So inflection point, this means concavity changes. Okay. So here are some practice problems we'll do Wednesday morning. So first, I want you to start with this quadratic, -x² plus 6x minus 5. Do the same sort of thing that we just did with the cubic. So find the intervals where the function is increasing, decreasing, concave up, and concave down. And then based on those, make a rough sketch of the function. Number 2, I want you to draw a graph for a continuous function, f of x, that satisfies the following criteria. So you want the first derivative to be negative from -infinity to -1, and between 2 and 4, and then positive from -1 to 2, and 4 to infinity, and equal to 0 at those spots. And then for the second derivative, it's positive between -infinity and 0, and between 3 and 6, and negative from 0 to 3 and 6 to infinity. Okay. And then last but not least, So take this function below. You probably are going to want to freeze frame on this. And looking at this picture, identify the intervals of this function where it's increasing, decreasing, concave up, and concave down. So here I'm giving you the function, and I want you to figure out where it's increasing and decreasing, where it's concave up and concave down. I will see you on Wednesday morning then. Bye.